We know that for a function to be differentiable at a point, it must be continuous at that point. We also know that if f of x is differentiable at a point a, then f prime of a is equal to the limit as x approaches a of f of x minus f of a, all over x minus a. Let's use the function f of x is equal to the quantity x minus 3 to a power of 1/3 to determine if a function is guaranteed differentiable at a point when it is continuous at that same point. The graph of f of x may look continuous, but let's verify this by showing that the limit of f of x as x approaches a equals f of a. Let's look at the graph when x is equal to 3. Notice that the function is defined at x equals 3, so we can evaluate the limit using direct substitution. If we substitute 3 for a, we get the limit of x minus 3 all raised to the 1/3 as x approaches 3 equals 3 minus 3 all raised to the 1/3, which is equal to 0. So, since the limit of f of x as x approaches 3 exists and is finite, f of x is continuous at 3. Now that we know the graph of the quantity x minus 3 all to a power of 1/3 is continuous at 3, let's see if this fact guarantees the function is differentiable at 3. We can determine if the function is differentiable at 3 by evaluating the limit of f of x as x approaches 3 from both the left and right directions. If the resulting limits are equal and finite, then the function is differentiable at 3. If they are not equal and finite, then the function is not differentiable at 3. Start by evaluating the limit of f of x as x approaches 3 from the left. Notice that 3 minus 3 is equal to 0, so the second term in the numerator will be 0. You'll be left with the quantity x minus 3 all raised to a power of 1/3, all over x minus 3. Notice that as x approaches 3 from the left, both the numerator and denominator become negative values close to 0. However, the numerator approaches 0 much faster than it does in the denominator, so the limit of this expression as x approaches 3 from the left is positive infinity. Now let's evaluate the limit of f of x as x approaches 3 from the right. Again, the second term in the numerator is 0, so you'll be finding the limit of the same expression as before, but evaluating as x approaches 3 from the right side. Both the numerator and denominator approach 0, but the numerator approaches 0 much faster than in the denominator, so the limit of the expression as x approaches 3 from the right is positive infinity. The limits of f of x as x approaches 3 from the left and right directions are both infinite. So the original function, the quantity x minus 3 all raised to a power of 1/3, is continuous at 3, but is not differentiable at 3. We can conclude that if a function is continuous at a point, it is not guaranteed that the function is differentiable at that point. It's important to remember that if a function is differentiable, then it is also continuous. However, if a function is continuous, it may fail to be differentiable.